Thunder. Thunder is the sound caused by lightning. Depending on the distance from and nature of the lightning, it can range from a sharp, loud crack to a long, low rumble brontide. The sudden increase in pressure and temperature from lightning produces rapid expansion of the air within and surrounding the path of a lightning strike. In turn, this expansion of air creates a sonic shock wave, often referred to as a thunderclap or peal of thunder. The study of thunder is known as brontology. Etymology. The D in modern English thunder from earlier Old English thunder is epenthetic, and is now found as well in modern Dutch donder cf. Middle Dutch donner, also Old Norse Thor, Old Frisian Funer, Old High German donar, all ultimately descended from Proto-Germanic ** thunres. In Latin the term was tanir to thunder. The name of the Nordic god Thor comes from the Old Norse word for thunder. The shared Proto-Indo-European root is *tan ar or *tar, also found in Gaulish Taranis. Cause. The cause of thunder has been the subject of centuries of speculation and scientific inquiry. Early thinking was that it was made by deities, but the ancient Greek philosophers attributed it to natural causes, such as wind striking clouds Anaximander, Aristotle, and movement of air within clouds Democritus. The Roman philosopher Lucretius held it was from the sound of hail colliding within clouds. By the mid-19th century, the accepted theory was that lightning produced a vacuum. The collapse of that vacuum produced what is known as thunder. In the 20th century, a consensus evolved that thunder must begin with a shock wave in the air due to the sudden thermal expansion of the plasma in the lightning channel. The temperature inside the lightning channel, measured by spectral analysis, varies during its 50 ms existence, rising sharply from an initial temperature of about 20,000 K to about 30,000 K, then dropping away gradually to about 10,000 K. The average is about 20,000, 400 K, 20,000, 100 deg C, 36,300 deg F. This heating causes a rapid outward expansion, impacting the surrounding cooler air at a speed faster than sound would otherwise travel. The resultant outward moving pulse is a shock wave, similar in principle to the shock wave formed by an explosion or at the front of a supersonic aircraft. In close proximity to the source, the sound pressure level of thunder is usually 165–180 dB, but can exceed 200 dB in some cases. Experimental studies of simulated lightning have produced results largely consistent with this model, though there is continued debate about the precise physical mechanisms of the process. Other causes have also been proposed, relying on electrodynamic effects of the enormous current acting on the plasma in the bolt of lightning. Consequences. The shock wave in thunder is sufficient to cause property damage and injury, such as internal contusion, to individuals nearby. Thunder can rupture the eardrums of people nearby, leading to permanently impaired hearing. Even if not, it can lead to temporary deafness. Types. Vavrek et al. N.D. reported that the sounds of thunder fall into categories based on loudness, duration, and pitch. Claps are loud sounds lasting 0.2 to 2 seconds and containing higher pitches. Peals are sounds changing in loudness and pitch. Rolls are irregular mixtures of loudness and pitches. Rumbles are less loud, last for longer up to more than 30 seconds, and of low pitch. Inversion thunder results when lightning strikes between cloud and ground occur during a temperature inversion. The resulting thunder sounds have significantly greater acoustic energy than from the same distance in a non-inversion condition. In an inversion, the air near the ground is cooler than the higher air. Inversions often occur when warm moist air passes above a cold front. Within a temperature inversion, the sound energy is prevented from dispersing vertically as it would in a non-inversion and is thus concentrated in the near-ground layer. Cloud ground lightning typically consists of two or more return strokes from ground to cloud. Later return strokes have greater acoustic energy than the first. Perception. The most noticeable aspect of lightning and thunder is that the lightning is seen before the thunder is heard. This is a consequence of the speed of light being much greater than the speed of sound. The speed of sound in dry air is approximately 343 m/s or 1127 ft/s or 768 mph 1236 km/h at 20 deg C 68 deg F. This translates to approximately 3 seconds per kilometer, 5 seconds per mile, saying 1001, 1002. Is a useful method of counting the seconds from the perception of a given lightning flash to the perception of its thunder, which can be used to gauge the proximity of lightning for the sake of safety. A very bright flash of lightning and an almost simultaneous sharp crack of thunder, thundercrack, therefore indicates that the lightning strike was very near. Close-in lightning has been described first as a clicking or cloth-tearing sound, then a cannon shot sound or loud crack/snap, followed by continuous rumbling. The early sounds are from the leader parts of lightning, then the near parts of the return stroke, then the distant parts of the return stroke.